Welcome in to everyone joining. Thank you for being here. Go ahead and get yourself ready. Grab a notebook, pencil, or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. Today we have a problem that covers circles, looking at circle problems. Go ahead and give this one a read. It is a word problem. And I think you should probably take about 3 to 4 minutes to try to solve this one. If you can do this in 3 to 4 minutes, you're in pretty good shape. If you can do it faster, obviously, that's better. And if you take longer, that's okay. Just get faster. So when you're ready, you can pause the video and check out how we do it here. Okay, so we have a river that's running under a bridge whose underside is a circular arch. That is the portion of a circle. The bridge spans 100 feet of water, and the highest part of the arch is 25 feet above the water. If the center of this invisible giant circle sits somewhere deep under the water at the origin, can you find the equation of the circle? So here is a little bit of a diagram of what I'm talking about, okay? So we have a bunch of water down here. I didn't make it very blue. Let's just pretend that's like all the water. And the portion of the circle that is physically a bridge, it's the underside of the bridge, is this circular arch, right? It spans 100 feet across the water. We also have that the portion of the circle meets 25 feet from the top portion of that circle. So it kind of gives you an idea of how far down this chord is. And we're tasked with finding the radius of the circle. That way we can write the equation of the circle. All right, so of course the equation of a circle is going to be x minus h squared plus y minus k squared equals r squared. So how do we use this 100 and this 25? That's really the question here. So if that's 100 across, and if I introduce some coordinate axes like a grid, that puts this point at an x value of 50. In fact, let me erase some of this water. So this point would be 50 on the x. What would the y value be, though? The y value would be however tall the radius is, but then minus 25 feet. Because the point on the circle is technically 25 feet lower than the radius, if that makes sense. The radius would take you all the way to the top, which is where the bridge is at. But that goes through some of the water. So if we were to subtract 25, that would give us just this height here. Right? That just makes sense. So using this point, we can plug this into our equation. Fortunately, where is our center? Our center is at the origin, so we can just use 0, 0 for our h comma k. That makes the math a little bit nicer. I could have made this problem tougher by putting the radius and putting the center somewhere else, like completely different, and fixing it somewhere. Be a more complicated problem, a very different problem if I did that. So let's plug in. We have 50 minus 0 squared plus r minus 25, also minus 0 squared. You don't really have to write the minus 0, but it's in the formula. And this equals r squared. You'll notice that we can solve for r because we're going to have r on both sides of the equation. In fact, we're going to have r squared on both sides of the equation. This is just a binomial expansion, which I've been doing plenty of this lately. Here we have r squared minus 50r plus, careful because negative 25 times negative 25, don't screw that up in the last step, is equal to 625. And here we have 50 squared, which is 2500. And this all equals r squared, so it's not even going to be a quadratic situation. You don't even have to worry about it being quadratic. They have r squareds on both sides of the equation, so those just cancel each other out. Perfect. And now we have that 2,500 plus 625. That's going to be 3125 equals to 50r. All right, this isn't necessarily the nicest number, but here you want to divide both sides by 50. And if you think you can't divide by 50, you're wrong. It's easy to divide by 50. Look, just multiply this by 2 instead. What does that give you? 6 to 50, and then move the decimal twice. 62.5. Very easy to divide by 50 or divide by 5. All right, so this is our radius. Does this give us the final answer? No, not quite. We have to put this equation in its form. So we're going to have x minus 0 squared, technically. I'll still put the 0 in there, even though it doesn't do anything to subtract 0. Plus y minus 0 squared equals 6250 squared. So really the goal of this was just to find the radius so that we can plug it into this nice equation. And then if you want to clean it up, feel free. Anyone know 62.5 squared off the top of their head? That should be about 3,906.25. Don't quote me on that. This would be the equation of the circle. Now, as I said, because the center is located at 0, 0 conveniently, I didn't give it some other location. Like, I could have just said this was a point, maybe 20, 80 or something. And from there, everything would relatively be the same, but I would have to shift all of my points. So like this x value would be 50 plus 20, and this y value would be r minus 25 plus 80 or whatever. But the math would work out the same. The r squareds would cancel, and everything would be proportionally the same, so that you'd get the same radius of 62.5. Okay, this is a nice little word problem application of the circle, and I kind of just popped the diagram on there. If you don't understand the diagram, or if you don't understand how to generate the diagram from word problems like this, my advice is to keep doing word problems, because that's the only way that you're going to see how those representations occur. You're also going to get some connections with like reality, because a lot of times we're describing some roughly realistic scenarios, such as a bridge whose underside is like perfectly circular. That might not always be the case. They might be a little longer sometimes. Maybe I'll give you a problem with an ellipse in the future. Hint, hint, wink. Title also kind of gives away that. But anyway, I think that's enough blab out of me. I'll catch you guys next time.